talk about elementary row operations. If you have a matrix 1, 2, 3, 7, 0, 4, 1, 9, 2. If you perform a row operation, you get another matrix. And we use this symbol to mean that the two matrices that you see, or we'll see in a moment, are row equivalent. This means row equivalent. One operation is you can interchange any two rows. In other words, you can interchange the first and the third row. That is, in their location of the first row, you put the third one. We did nothing to row number 2, and row 3 is now row 1. And you might want to denote what you're doing so somebody who's looking at your work would know that you interchange rows 3 and row 1. That's one elementary row operation. Another row operation is you can multiply any row by R. But R can't be 0. You can multiply any row by any number you want. For example, I can take row 2 and multiply it by 3. So I'm not doing anything to row 1. I am multiplying every entry in row 2 by 3. And I am not doing a thing to row 3. The third elementary row operation is you can add a multiple of any row to another row. In other words, we can replace the first row with row 1 plus 2 times row 3. So row 2 and 3 are not being changed. And I am going to take 2 times, I'm going to take row 1, 192, and I am going to add, 192 is row 1, and I'm going to add 2 times row 3. 2 times row 3 would be 2, 4, 6, and when I add them I get 3, 13, 8. 3, 13, 8. All of the matrices in front of us are row equivalent. You can interchange any two rows you like. You can multiply any row by any number you want except 0. You can't multiply by 0 because multiplying by 0 will make all the entries 0. You can't do that. You can multiply by any number you want except 0. And you can add a multiple of any row. You can take any row, multiply it by something, and add that to another row. Now, I like to combine 2 and 3. We'll call it star. You can add a multiple of one row to a multiple of another row. In other words, you can multiply this by 2 and multiply this by 3 and add them up, and that will be the new row 3. Or if you prefer, the new row 2. You could replace one row with the multiple of that row plus the multiple of another row. So I like So that's combining step 2 and 3. So those are what I will call the 4-row operations. That is elementary row operations. And again, 2 matrices are said to be row equivalent if you can go from this matrix, say, to this matrix by performing elementary row operations. You can get from this matrix to this matrix by performing elementary row operations. First, we interchange 2 rows. That's an elementary row operation. Then, from this matrix to this matrix, we multiplied a row by 3. And then to go from this matrix to this matrix, I added 2 times row 3 to row 1. This last matrix is row equivalent to the first one. In fact, they're all row equivalent to one another, because to go from one to another, we just perform these elementary row operations. Let's talk about this a little bit more. So all the matrices that I'm about to write down are row equivalent to one another. 1, 7, 3, 2, 0, 1, 4, 3, 1. I am going to double the first entry. So we write it down, 2 times row 1. I meant to say double the first row. So we get 2, 14, 3. I'm not doing anything to the other 2 rows. I know I'm not doing anything. I didn't write anything on the side saying I'm doing something. But over here I did. Okay? I am going to now interchange row 2 and 3. Row 2 becomes row 3. And for the record, row 3 becomes row 2. So row 1, I didn't do anything to it. And I better not do anything to it, because I didn't write what I'm doing. Row 3 becomes row 2, and row 2 becomes row 3. The 3 matrices in front of us, they're row equivalent. I'm going to double row 1, and I'm going to add on 3 times row 2. I'm going to put the result down here. So row 3 is not being changed, and row 2 is not being changed. But row 1 is being changed. I am taking 2 times row 1, which is 4, 28, 6. I'm taking 3 times row 2, which are those numbers, and I'm adding them up. This is 2 times row 1. This is 3 times row 2, and I'm adding them. 16, 37, 9. And that is, and for new, that's the new row 1. I know it because I put it by row 1. I could have put it by row 2, but I didn't. 16, 37, 9. Do you have to do all 3 of them? No. No. Any number of them. You can do some operations 3 times, 4 times. You can do some of these elementary row operations just 1 time. For example, so here's a new problem. For example, if you have the matrix 1, 2, 3, 4, 2, 1, 0, 3. It is row equivalent to this one. I interchanged the first 2 rows, and I interchanged rows 3 and 4. Okay? And that's all I'm going to do. These 2 matrices are row equivalent. That's what that symbol means. You could interchange any two rows you like. You can multiply any row by any number other than 0 that you like. You can add a multiple of one row to another row. You can add a multiple of one row to a multiple of another row. Those are called the 4. We'll call X the fourth one. There are 4 elementary row operations that you can do. This completes the section on elementary row operations.